How does parity work on a RAID 5 array? I'm looking to build a nice little RAID array for dedicated backups. I'd like to have about 2-4 TB of space available, as I have this nasty little habit of digitizing everything. Thus, I need a lot of storage and a lot of redundancy in case of drive failure. I'll also essentially be backing up 2 to 3 computer/home folders using one of the Time Machine clones for Linux. This array will be accessible over my local network via SSH. I'm having difficulties understanding how RAID 5 achieves parity and how many drives are actually required. One would assume that it needs 5 drives, but I could be wrong. Most of the diagrams I've seen have only yet confused me. It seems that this is how RAID 5 works. Please correct me as I'm sure I'm not grasping it properly. It seems that drives 1 to 3 appear and work as a single, massive drive, capacity number _of_ drives, and the parity drives back up those drives. What seems strange to me is that I usually see 3+ storage drives in a diagram to only 1 or 2 parity drives. Say we're running 4 1 TB drives in a RAID 5 array, 3 running storage and 1 running parity. We have 3 TB of actual storage, but only have 1 TB of parity? I know I'm missing something here. Can someone help me out? Also, for my use case, what would be better, RAID 5 or RAID 6? Fault tolerance is the highest priority for me at this point, since it's going to be running over a network for home use only. Speed isn't hugely critical.
It registers each corresponding bit from each drive. If you lose any drive, you can rebuild the missing data. For background, assume that D is the XOR of the other columns, then as long as you only lose 1 drive, you can figure out what you lost. Sometimes the stripe bit will be distributed across the drives, but the concept is the same. So for RAID 5, no matter how many drives, you only need 1 drive for parity equal or bigger than the smallest drive in the array you want to RAID. RAID 5 for personal use is probably best as computational complexity is much lower than RAID 6. RAID 6 is more complicated using Galois fields to compute parity, and that can tax parity computations. However, you can lose more drives. But if you rebuild your array as soon as you get a single failure, you should be fine sticking with RAID 5.
Here's what I think is a better diagram to show how parity works in RAID 4 and RAID 5. RAID 4. RAID 5.
I would recommend reading this Wikipedia article on RAID 5 and RAID 6. This URL. RAID 5 writes a parity block in each strip, so for strip A of a 4-disk array it writes a parity check on the 4th disk, with data on disks 1, 2 and 3. For strip B, the parity block is on disk 3, with data on disks 1, 2 and 4, etc. If say disk 4 fails, the data can be recovered for strip B as you know the data on disk 1 and 2 and have the parity check on disk 3. If strip B had a parity of 2 and disk 1 has data of 1 and disk 2 data 0, then disk 4 must have had data equal to 1, so the disk is written with data equals 1. Whole disk can be recreated this way. RAID 6 extends this by having 2 parity blocks per stripe. Regarding space for RAID 5, you only ever lose 1 disk's worth of space to parity, as it only writes on parity block per stripe, while with RAID 6 you will lose 2 disks but can also lose 2 disks rather than the one you can lose in RAID 5 Smile. The Wikipedia article explains this better.
RAID-5 uses one drive for parity, regardless of how many data drives there are in the array. This means that it becomes more efficient, in terms of usable space, the more drives that are added. Parity is achieved by doing an XOR operation across the same block in each drive. The contents of the parity drive is adjusted such that all drives XOR to 0. This does mean that RAID-5 is restricted by the smallest capacity of all drives in the array. RAID-6 is similar except that 2 simultaneous drive failures can be tolerated. This is useful because the process of resilvering an array after a single drive failure may be stressful enough to cause a second drive to fail.